Hello everyone, welcome to ashatech.com. Today we once again meet to discuss some more concepts of mechanical engineering science. In our past lecture, we are going to review what we talked about, and we talked about stress. And we said stress is given as the load per unit area. Load over area of cross section. This we said can be in newtons or kilonewtons, giganewtons or meganewtons. It can be in kilonewtons, etc. Divided by this area is in meter squared. Now, this can be tensile stress, it can be compressive stress, depending on the condition of the load being applied on an object. Therefore, this stress sigma will equal to, if the force is P and the area of cross section is A, then sigma, which is stress, will equal to force P over area. This is in maybe kilonewton. This one is in square meters. How about strain? We also talked about strain given by this symbol, and we said is equal to the change in length divided by the original length of the object. So this strain can therefore be given as sigma L, or small change in length divided by original length L. And we said basically this strain can tell us how much deformation of the object has happened when loaded either in a compressive mode or in a compression or under tension. Now, having reviewed this, let us directly go to the concept that we are going to discuss today, called Modulus of Elasticity, or Young's modulus, which is given as capital E. Now, within the elastic limits of materials, or within the limits in which Hooke's law applies, or in which Hooke's law is valid, it has been shown that stress divided by strain is equal to a constant. Now, this constant given as given by this symbol E is actually termed as the modulus of elasticity, or what we can call Young's modulus. This is basically a constant for each and every material has its own modulus of elasticity, and therefore this kind of a constant is valid only in the limits of Hooke's law. In other words, beyond the limit of proportionality, when this object is subjected to loading, beyond the limit of proportionality, it is no longer having this constant. In other words, it has lost it. Therefore, in that region, stress over strain is not a constant. But within the limits of proportionality, stress over strain is equal to a constant as long as Hooke's law is applied or is valid within that region. Now, we know that sometimes the loading condition is complex. So still in cases where there is complex stress, this simple form of Hooke's law may not apply, and therefore any misapplication of it could prove dangerous. So you have to be careful when applying this Hooke's law, this kind of Hooke's law, where stress over strain is equal to a constant, giving you the modulus of elasticity. So we have said in complex cases, stress over strain may not be a constant. So this must be noted with great care. Now, in most engineering applications, strains do not often exceed about 0.03 or what we can give as 0.3%. So that the assumption used in the text above, that the deformations are always small in relation to original dimensions, is actually generally well found, and therefore the actual value of Young's modulus for any material is normally determined by carrying out a standard tensile stress, a standard tensile test on a specimen of the material. In other words, if you carry out a tensile test, you will come up with a graph of this kind. So this is because when you load this object, you are going to plot values of stress against strain, or you can plot values of load, because each and every load will give a corresponding extension. So you can plot a graph of load against extension, or stress against strain. This can be stress against strain, or can be load against extension. Now, if this is O, this is A, this is B, this is C, let me just call this one B. It means from here, this point to this point, Hooke's law is applicable. Hooke's law is valid, and it means, therefore, if I wanted to find the Young's modulus, which is a constant for this kind of material, it could be for ductile materials, for example, a copper wire, or any other particular material which can be rolled into a shape, or where when we plot the values of stress against strain, as long as the elastic limit is not exceeded, a straight line graph is going to be founded. And therefore, if we look for the gradient of this line, the gradient of that line, will therefore give us what we call Young's modulus. So if asked, modulus of elasticity, having carried out that tensile test experiment, then if you plot the values of stress against strain, you are going to look for the gradient of this straight line graph, and the gradient will therefore give you modulus of elasticity. Gradient will equal to Young's modulus. Now, in most engineering applications, we are going to find out that this E, or Young's modulus, is going to always be approximately 200 giga-Newton per square meter, or